Actually exactly the same as what we did yesterday, except we've got a little bit of context here. So this problem says, while playing tennis, anyone ever played tennis before?
Yeah.
No. Yes.
Some of us, okay. Matt is 12 meters away from the net, which is 1 meter high. He needs to hit the ball so that it just clears the net and lands 6 meters past the net on the other side. At what height should Matt hit the tennis ball? Here's a little diagram basically going over what it's talking about. So the net, you guys know what a tennis net looks like? It's like this tall, right? It's not very high up. That's this guy right here. CB is my net. And we can see that it's labeled at 1 meter tall, which is like 3 feet. Okay. Matt is 12 meters away from the net. So this is Matt. And the distance between the net and him is 12 meters. What name can we give this purple segment based on the points that it starts and ends at? Yeah, Xavier? BD. Right? He needs to hit the ball so that it clears the net, which means goes right over it, and lands 6 meters past the net on the other side. So he's going to throw the ball up in the air. It's going to reach point E. He's going to serve it. It's going to follow this line all the way down. It's going to just clear the net and land right here at point A. Okay, it's going to land right here at point A. 6 meters past the net. What can we name this little 6 meter segment here? AB. Right? It goes from point A to point B. Actually. So we have all these numbers, we have all these distances. What distance do we not know? We don't know what X is. Right? What segment are we trying to find the length of? ED. That's this segment right here. At what height should he hit the tennis ball? Just like with any word problem, any problem with a specific context, if we don't understand what the problem is talking about, Jeremiah, focus up here for me. If we don't understand what the problem is talking about, we're not going to understand what we're solving for or what to do. Are there any questions about the context? Even if you have no idea what tennis is, hopefully you at least know that you throw the ball up and hit it over the net, right? So that's what we're dealing with. So what we have here is one really, really big triangle made up of 2 smaller triangles. See this little guy right here, triangle ABC? If we want to set up a proportion, we got to split these 2 triangles up so that we have something that looks a little bit more like what we did yesterday. All right? Bless you. So before we set up a proportion, let's split it up. My small triangle is triangle ABC with AB on the bottom. CB is my little height. And then I got AC going across. Give me a thumbs up if you see how I got this little triangle right here. I just took it off the top here. Basically, I covered the rest of my triangle up. I see this little guy circled in yellow. I just pull that guy off. Boom, there's my little triangle. What is this pink length at the bottom of this triangle? 6 meters. And what's this teal height? What's CB's length? 1 meter. We can see in our original diagram that those lengths are clearly listed, 1 meter and 6 meters. Okay? Everyone with me so far? Yeah? Okay. Now I'm going to take this whole big triangle. So I'm essentially going to ignore CB. Okay, if I cover up CB just like that, you guys see one big triangle there? Yes, no? Yes, we see one big triangle, okay? So my left side is ED. All right? This whole top side is EA. And the most important thing to note is that the base of this triangle is two different segments. Hey, Mr. Corbis. See how we got this pink 6-meter segment and this purple 12-meter segment? Here's what that base is going to look like. I've got my little pink segment right here, and I've got my much larger purple segment right there. And I know a lot of you guys don't have like different colors. I'm just doing this so you can see how we're splitting this up, just like that. Do you need someone, Mr. Corpse? Oh yeah.
Question.
Sure.
You do the
All right. Sorry about that. So we see this base segment is kind of split into two pieces, this little pink part and this little purple part. What's the length of this pink segment again? 6 meters. What's the length of the purple segment? Bless you. 12 meters. Okay. So the entire base of this triangle, this whole length from A all the way to D, how many meters would that entire length be? 18. How did you get 18?
Because 6 plus 12.
6 plus 12 gives me 18 meters. You guys all see that?
Yes.
Okay. Because if we're going to get an image that looks like what we did yesterday, I just need one number on each side. Number, 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 and an X. So I've got a base and I've got a height for my small triangle. I now have a singular base for my large triangle. What's the height?
6.
What does it say the height is in the diagram?
X.
X. We don't know what that side is. That's what we have to solve for. It's kind of hard to see, isn't it?
No.
No. Whoops. There we go. Okay. So the reason why we need to split this up into two images, I know it seems like it's doing too much, but if we don't, you're going to look at this and go, oh, 6 and 1, 12 and X, right? You're going to set up your proportion with the number 12 in there, but that's not the entire base of my big triangle. If I split it up into two separate triangles, I'm much more willing or able to see that I got to add these together to get my base of 18. All right? That's what this note here is for. Go ahead and highlight that whole thing. Don't forget to combine our two base lengths together if they're separate. Okay? Very, very important. They're not always going to be separate. We'll see on the next page what it looks like if they're not separate. But if they are, we have to consciously make sure we're adding them together. Now we can set up a proportion just like we did before. I got my base and my base. I got my height and my height. Okay? So I'm going to do my bases here in yellow, 6 meters and 18 meters. My heights of 1 meter and X meters in pink. When I set up my proportion, it's going to be a fraction over a fraction. What is this first fraction here going to look like? Say what? 6 over 18. Sure. We'll do our yellow one, 6 over our other yellow one, 18. 6 over 18. My yellow side over my yellow side. Small yellow over large yellow. So what's my matching fraction going to look like over here? Well, I've got my small triangle on the top. So what's the height of my small triangle? 1 meter. I got my big triangle on the bottom. What's the height of my big triangle? X. That's what we're trying to solve for. You guys see how we set that up? Same as yesterday, except we just had to do a little extra work of splitting up the picture. Now I'm going to do exactly what I know how to do. Cross multiply. If I cross the 6 and the X, I get 6X. And if I cross 18 times 1, what is 18 times 1?
18.
Just 18. So this turns into 6X equals 18. Am I going too fast?
No.
Am I going too slow?
No, you're going too fast.
I'm going too fast? Okay. I appreciate you letting me know. Are we comfortable with the cross multiplying?
Yeah.
Is that a fingernail?
This
Yeah.
is a hole in the
So.
thing. I see what you mean. What do I need to do if I want to get x all by itself?
Divide both sides by 6.
Divide both sides by 6. These 6's go away, leaving me with x equals, what's 18 over 6? 3.
Quattro. You guys are so smart.
Quattro is 4.
Oh.
3.
Threes.
Trace, yep, 3. Tres. Is that my final answer? We've done word problems before. What am I missing?
Meters.
Units. Thank you. What are my units here?
3 M's.
3 M's. What is that? Millions?
Meters.
3 meters. There's my final answer. So the question asked, at what height should Matt hit the tennis ball? He should hit it when it's 3 meters in the air.
How are you going to tell when it's 3 meters?
It's obviously not an applicable problem, but it is a way that we can take something in the real world and see how these proportions that we talked about would match up. Obviously, he's not going to be like, oh, it's at 3 meters, time to, you know what I mean? But mathematically, that's what it would look like. He could. You never know. Quick show of thumbs, how much sense is that making? Thumbs up makes pretty much the same sense as yesterday. Ooh, thumbs down, thumbs sideways. Okay, if your thumb is sideways or down, think of a question you can ask me, because I can't read your minds. And if you don't want to ask it now, please ask me later. Yeah, go. away.
You should do that when you make
Someone will snatch it.
Yep, you're like, you didn't know that?
All right, we got this glued in?
No.
No.
Oh, my apologies.
So I was able to procure a box of glue sticks. So each group got 2 new glue sticks, 1 for each pairing. 2 in the, 1 glue stick in the front, 2, 1 in the back, 2. Please go easy on them, okay? All you need is 1 line around the edge of your paper. You don't need to color in the middle with the glue. Please don't do that. It's a waste of glue and you don't need it. All I literally do is hit the 4 corners and nothing is falling out, So don't overdo it. If you have your own glue, use it as much as you want. I don't care about that. But if you're using my glue, please go easy on it. Just use it around the edge, okay? So, example A. We're doing the same thing. We're finding missing side length X. We got to split our image up into 2 triangles and then set up a proportion. All right?
Yes.
So, my first triangle, I'm going to look at my little guy here. I'm going to do it in yellow. Okay, there's my little triangle. What is the height of this little tiny triangle here? My height is X. That's what we're going to solve for. What's the length of that tiny triangle's base?
6 feet.
6 feet. So I'm going to do a little tiny triangle here with a height of X and a base of 6. And in fact, I'm going to put a 1 in the middle, just so we really know which part of this triangle we're talking about. Everybody cool on that? The little one?
Yeah.
Okay. Now we got to look at the big one. This huge triangle that completely encompasses that small triangle we just talked about. They're in pink. Okay, I'll put a little 2 in the middle. All right. What is the height of this large pink triangle?
8 feet.
8 feet. And what is the length of my base?
6 feet.
6 feet. You guys agree?
Yes.
Let's take a look back at the giant box that we highlighted in bold letters and let's all read it together.
12.
Ready? Start with the word 4. 3, 2, 1,
For
go.
our big triangle, don't forget to combine the 2 base lengths together if they're separated.
Okay. So if my 2 base lengths of the big triangle are separated, I need to combine them. Let's take a look back. This big pink triangle has a base of what?
12.
12. 6 plus 6. It wouldn't make sense for the big triangle and the small triangle to both have a base of 6 because clearly one's bigger than the other,
Yes.
right? But our first instinct is to go, oh, my other number here is 6, it must be 6. That's why I really want to stress how important it is that we're combining the base lengths if they are separate like this. Okay? So this whole base here is 6 plus 6, which is 12 feet. Everyone cool on that? Yeah? Okay. Good. Now I've got my 2 triangles. I clearly see what my proportion is I need to set up. I'm going to go up here. 1 fraction equals another. What's my first fraction going to look like?
X over 6.
X over 6?
Oh, X over 8.
X over 8. Now I know it's confusing because these are both yellow. But if I do my left side over my left side, I get X over 8. And then if I do my base side over my base side, What should my second fraction look like?
6 over 12.
6 over 12. All right? Exactly the same setup, exactly the same proportions as yesterday. We just got to split our triangle up at the beginning. To cross multiply, I just make this little bubble X. I'm going to circle the numbers or letters that are across from each other, just like that. All right? So on one side, I have 12 times X and what do I have on the other side?
6 times 8.
6 times 8. Very nice. What is 12 times X?
12x.
12X. And what is 6 times 8?
48.
48. What would I need to do on both sides to get X all by itself?
Divide by 12.
Divide by 12. And how many times does 12 go into 48?
4 times.
4 times. X equals 4. What?
Feet.
Feet. Great job. I appreciate your help. 4 feet. So if this little guy over here is 4 feet, let's see real quick if that makes sense. If my base goes from 6 to 12, how much bigger are we getting from 6 to 12? Twice as big.
Yes.
6 times 2 is 12. Well, if my small height is 4 and my large height is 8, what would I multiply 4 by to give me 8?
2.
2. So because that scale factor is the same, I know that I did this correctly. It's like a dilation where we took triangle 1, we made it twice as big, now we have triangle 2. Okay? Any questions on that first one? Okay. Take a look at the second one. What do I notice about this image that's different than my other two?
The bottom is X.
The bottom is X, that's right. What else do I notice about the bottoms here?
It's not separate.
And they're not separate. It shows the whole big base is 15. Yeah, you guys both said the same thing. So, if I look at my small triangle right in here, okay, I'm going to draw that one off to the side. Oops. What is the base of my little triangle?
X.
X. What is the height of my little
3
triangle?
meters.
What?
3 meters.
3 meters. Good. Said so fast. 3 meters. Right? Now, my big triangle is this huge one all the way around. It encompasses my little yellow triangle. Okay. I'm going to draw that one too.
No, from C.
What is the height of my big pink triangle? How tall is it? 5 meters, thank you. And how long is the base? 15. So in this problem, we don't have to combine the bases because look, this 15 meters stretches all the way across the bottom of my big triangle. So that's why this note on the previous page says we're going to combine the base lengths together if they're separate. They won't always be. It's up to you to determine if they're separate or not. All you got to do is look for the arrows. If it goes all the way across, they're not separate. If it's halfway is 6 here, halfway is 6 there, that's when I got to combine them. Okay? Pretty self-explanatory. What proportion can I now set up?
Your fraction
That's right, my fractions. What's my first fraction going to look like?
3 over 5.
3 over 5. 3 over 5 equals
15. Oh. 15, x over 15.
That's right. We want to make sure that my small triangle is across the top and my large triangle is across the bottom. Okay? Do me a favor, cross multiply and see if you can solve for x. I'm going to come by and take a look as you guys are working. I'm going to see if you can do it on your own. Now that we've set it all up. Nice job. Nice job.
I'm actually good.
9 what?
I actually, right.
What? Nice. Good. You guys already beat me too. Before I did IC2. 5 times x is 5x equals 3 times 15. Oh, this is easy. Good. So we got 3 times 15. So with 3 times 15. 45. Sorry, I'll get you. So 45 on one side. Equals. Group up my other little cross multiply. We got this circle. Now we got to do this one. What's 5 times x? Don't think too much. 5x. Yeah, I can't do anything with that, so I just got to stick them together. 5x. Now, if I want to get x all by itself, I'm going to divide. What should I divide both sides by? What's in front of the x? See how here we had 12x and we divided by 12? I got 5x. I'm going to divide both sides by 5. So do over 5 over 5. And then all we need to do is do that little x over 60 equals 7 over 70. Yeah, 70x equals 420. 60. Yep. Good job. It really depends. And honestly, it doesn't matter as long as what you're setting up is corresponding sides over each other and the same triangle on the same level. So you know how x and 7 both come from the small one? Those are both across the top. 60 and 70 are from the big one. They're both across the bottom. Right? Now, my bottom side, my pink side, is one fraction. 70 and 7 are both pink. That's one fraction. My yellow side on the top is another fraction. So 2 things to make sure everything's all lined up. Okay? 9. What? Okay, when I cross multiply, I'm going to circle up my terms going across and going across. What is 3 times 15? 45. And what is 5 times x? 5x. If I want to get x all by itself, what do I need to do on both sides? Divide by 5. It's all right. And I get x is equal to
9 meters.
9 meters. Not too bad, right?